Hi everybody, welcome back to the Feynman technique. Today we'll be solving this integral, the integral from 0 to pi over 2 of the natural log of cosine to the fourth x plus sine to the fourth x dx. And to solve it, we're going to be using this fact that I showed in my example number 43 video. That is the integral from 0 to infinity of the natural log of x to the fourth plus 1 over x squared plus 1 dx is equal to pi natural log of 2 plus the square root of 2. And showing this is it's quite a lengthy process, so that's why I'm just going to use it in this video. I already showed it on this channel, so I'm going to be using that fact to solve that integral right there. All right, so the first thing we're going to do is we're just going to start with this. And we're just going to make the substitution that x is equal to tangent theta. All right, and from that we can get this. We can get that the integral from 0 to pi over 2 of the natural log of tangent to the fourth theta plus 1 d theta is equal to pi natural log of 2 plus the square root of 2. Because if we make that substitution, we get dx is equal to secant squared, I already have this theta, all right, secant squared theta, d theta. And this x squared plus 1 would become tangent squared theta plus 1, which is secant squared theta, which would cancel out with our secant squared theta right there. So that's what you get. And of course, the bounds of integration, if x is 0, then tangent theta then theta is 0. If x is infinity, then theta is pi over 2. So we end up with this thing right here. All right, so what does that mean? Well, we can rewrite tangent to the fourth theta like this. We can rewrite this as sine to the fourth theta over cosine to the fourth theta, right? And we can rewrite this 1 as cosine to the fourth theta over cosine to the fourth theta. All right, so what does this mean? Well, you can see that this is just going to become sine to the fourth theta plus cosine to the fourth theta over cosine to the fourth theta. So we have this now. We have the integral from 0 to pi over 2 of the natural log of sine to the fourth theta plus cosine to the fourth theta d theta minus the integral from 0 to pi over 2 of the natural log of cosine to the fourth theta d theta. And that, of course, is equal to pi natural log of 2 plus the square root of 2. All right, so this is actually what this is the integral we set out to find the value of right there. So if we know the value of this, then we know the value of this. And actually, we do know, well, we don't. So I'm actually going to use King's property to show this. I've showed this before, but it's worth showing again. So we know this is true. We know this is true, so I'm going to erase everything else and just start from there. All right, we don't need this part anymore either. So now, all we need to do is show the value of this thing right here. All right, First, let's rewrite it like this. Let's rewrite that as 4 times the integral from 0 to pi over 2 of the natural log of cosine theta d theta. And let's set that equal to I. All right. So this is just I. Okay. Well, let's see. Let's use King's property on this. Remember King's property, it says that the integral from a to b of f of x dx is equal to the integral from a to b of f of a plus b minus x dx. Actually, let's call this 4I, and we'll just make I equal to this. There. That'll be easier. Okay, so what does that mean for this? Well, if we apply King's property, we know that this is equal to this. I will also be equal to the integral from 0 to pi over 2 of the natural log of cosine of a plus b minus x. That would be pi over 2 plus 0 minus x. In other words, pi over 2 minus x. The cosine of pi over 2 minus x is sine of x. Okay, so we have I is equal to this, and we have I is equal to this. Well, that means that we can say that 2I is equal to the integral from 0 to pi over 2 of this plus this. And using the properties of logarithms, we can just say that this is the natural log of cosine theta sine theta d theta. Okay. Well, that's not great yet. But what if we had a 2 there? Then we'd have the double angle identity for sine. So let's put a 2 in there. Let's just put a 2 right in there. Okay, so now this is actually going to become sine 2x. But what did we do by adding a 2 inside that parentheses? We actually added the integral from 0 to pi over 2 of the natural log of 2, didn't we? So we need to subtract that. So we subtract the integral from 0 to pi over 2 of the natural log of 2 d theta. And this is just negative pi over 2 times the natural log of 2. All right. So let's just rewrite that up there. This is minus pi natural log 2 over 2. All right. And of course, let's rewrite this as natural log of sine 2 theta. Okay. Well, let's see. Now we can make the substitution. Let's just say phi, we'll let it, phi is equal to 2 theta. Therefore, d phi is equal to 2 d theta. All right. Well, we don't have a 2d theta, but we can make ourselves have a 2d theta by just going like this, 2 and then 1/2. All right, so now we have this. We have 2I is equal to 1/2 the integral from 0 to pi of 2, well, natural log of sine phi. I said phi before, it's phi. 1/2 the integral from 0 to pi of, that's our d, okay, yeah, and then d phi minus pi natural log 2 over 2. Okay, next step is we want to break this up into two separate integrals, don't we? Okay, so let's break that up into two separate integrals, and I'll put that minus pi natural log 2 over 2 over here. Minus pi natural log 2 over 2. Crappy natural log. All right. So the first interval will be going from 0 to pi over 2, and then we need plus 1/2 the integral going from pi over 2 to pi of the same thing, natural log sine phi d phi. Okay. Well, let's see. I would rather have the same bounds of integration. So what I'm going to do is I'm just going to use a trick here. I'm going to subtract pi over 2 from the bounds of integration on this one. That just means I have to add a pi over 2 into that phi right there. All right, so I'm subtracting pi over 2 to get 0 to pi over 2 again. And then what is sine of phi plus pi over 2? Well, sine starts here and goes like this. And if we add pi over 2, that means we are, if we add pi over 2 to the phi, that means we are, see, adding means you move it to the left, right? So, okay, moving that thing to, all right, this is sine. Sine phi plus pi over 2 would move this to the left, so that would be cosine. So this just becomes natural log of cosine phi. Okay, but what do we know about these two things? These are equal to each other, aren't they? We already showed that. We showed that the integral from 0 to pi over 2 of the natural log of cosine something d something is the same as the integral from 0 to pi over 2 of the natural log of sine something d something. So, and what is that something? Actually, that thing is I. So this is just 1/2 I plus 1/2 I. So this whole thing right here just becomes I. Let me go over that one more time. We know that the integral from 0 to pi over 2 of the natural log of sine phi d phi is equal to the integral from 0 to pi over 2 of the natural log of cosine phi d phi, because we already showed it here. They're the same things. We used King's property to show that. So they're equal to each other. Not only are they equal to each other, but they are actually equal to the thing that we want to find. So this is 1/2 I plus 1/2 I. In other words, that's just I. And then if we subtract that I from both sides, we are just left with I is equal to negative pi natural log 2 over 2. Okay. Well, so now what do we have? This is 4i. So 4i is going to equal to negative 2 pi natural log, natural log 2, right? 4i is going to be equal to 4 times this. So, yeah, negative 2 pi natural log 2. All right. So this right here just becomes minus 2 pi natural log 2. In other words, plus 2 pi natural log 2. All right. So now we basically have it. We have that this integral right here plus 2 pi natural log 2 is equal to pi natural log of 2 plus the square root of 2. So let's just do some algebra. That means this whole thing right here, this whole thing is equal to, we'll have this pi natural log, I don't know why I keep making my natural logs like that, natural log of 2 plus the square root of 2 minus 2 pi natural log 2, right? Yep. This minus this is equal to this. Okay. So what can we do? We can factor out a pi. And then let's make this a minus natural log 4, using the properties of logarithms. So that way, we can just go ahead and make this pi natural log 2 plus the square root of 2 over 4. All right, and that's it. That is the answer. Well, guys, I hope you enjoyed that.